Now students, let's study some preparation of some addition polymers. So we are studying preparation of some addition polymers. Under this, the first one is polythene, which we have already studied the mechanism. That means the N unit of ethene by free radical mechanism or high temperature process is being converted into polythene. This is ethene, undergo polymerization, and you get polythene. This polythene is being divided under two categories with a short form of LDP and HDP, that is low density polythene and high density polythene. It's just the mechanism which has been changed, that is the conditions have been changed and the properties of this polythene has been changed so that we can use in the day-to-day lives in a different ways. So first, for the low density polythene, what are the conditions which are being using is, first, the high pressure is being required. That is around 1000 to 2000 atm. Temperature is around 350 to 570 Kelvin. The catalyst which we are using is the presence of O2 or peroxide initiator. The properties which we are getting by the preparation of this is, they are poor conductor of electricity, they are chemically inert, and they are being used for making flexible pipes, toys. So these are the properties, these are the uses, and this is the conditions under which they are being produced. So for high density polythene, what are the conditions we have been using? The pressure is around 6 to 7 atm. Temperature is 333 to 343 Kelvin, and the catalyst which we are using is tri-ethyl aluminium and titanium tetrachloride. This is a catalyst which we are using. This is which has to be remembered by you. Okay, the catalyst name has to be remembered by you all. It is also called as Ziegler-Natta catalyst. If you are not able to remember with these names, you should remember with the Ziegler-Natta catalyst, and you can write on an arrow Ziegler-Natta catalyst. And the solvent which we are using is hydrocarbon. That means the preparation takes place in the presence of hydrocarbon solvent. We are getting a closed pack structure. So closed packing structure is being obtained by this process. Therefore, they are having a high density polythene. So the uses are buckets बनाने में, dustbins and etc. Okay, so this is how the LDP and STP has been produced. Because of the close packing structure, they are being called as a high density polythene, and the conditions are being different, and they are being used for making dustbins, buckets and etc. Fine. Now we proceed with the second one now. The second one is polytetrafluoroethene. Polytetrafluoroethene. It is named as Teflon. You already have studied the name of Teflon, which are the coating on the non-stick cookwares which are being used. And the monomer which we are using is CF2 double bond CF2. This is a monomer which we are being using, and the name is tetrafluoroethene. Now this is the name of the monomer, CF2. So the end unit of this has been used under high pressure, or catalyst which has been used is persulfate catalyst. High pressure is being required, and the mechanism which we are using is again free radical mechanism. And they are being able to produce Teflon. And what are the uses of this Teflon? It's a non-stick surface, I already told you, of cooking utensils. It is also used for making gaskets. And the property, if I say why they are being used, the property is they are chemically inert. So we proceed with the third one now, which is polyacrylonitrile. For this, the name is PAN also, polyacrylonitrile, PAN, PAN, also being called as Orlon. It can be named in any way. In papers it can come in any way. And the monomer is acrylonitrile. This is CH2 double bond CHCN. Now this will become a side chain. Okay. So how the polymerization take place? Let's see. The end unit of this has been used. This becomes the branch under the peroxide catalyst. It results in the formation. It's a double bond over here, sorry. And this is how that takes place. CH2, CH, CN, and this is N. Now this is PAN. The monomer is acrylonitrile. Okay, and the catalyst which we are using is the peroxide catalyst. So what are its uses? It has good resistance to stain, chemical, insects and fungi. Okay.